Ever wondered how Netflix recommends movies that you might like? It's not magic, nor guesswork, but a methodical process driven by algorithms. Picture an intricate web of data spun by millions of users and their preferences. Now imagine an entity that navigates this complex web, grouping similar preferences together, making sense of the chaos. This is the realm of data science, with k-means clustering as one of its most popular tools. It's all about clustering, specifically k-means clustering. So, what is this k-means clustering we're talking about? Well, imagine you're at a party with a diverse group of people. You're the host, and you want to create groups for different activities based on common interests. But how do you go about it? You could make educated guesses, or you could use the k-means clustering algorithm, a scientific approach to categorizing or grouping data. In this context, the K stands for the number of groups or clusters you want to create. The process begins by randomly picking k individuals from the party as initial group leaders or centroids. Now each guest is assigned to the group whose leader they share the most in common with. So if you're a cat lover, you're likely to join the group led by another cat aficionado. But here's the catch. The group leaders are not fixed. They change based on the interests of the group members. So if a group of cat lovers suddenly takes an interest in dog videos, the group leader might change to a dog enthusiast. This process of recalculating the group leader, or centroid, and reassigning guests to groups continues until there's no significant change in group leaders, or a certain number of rounds have passed. Essentially, it's all about finding the mean or center point of data clusters. So whether it's categorizing guests at a party or analyzing complex data, k-means clustering offers a practical and dynamic solution. So, to wrap it all up, k-means clustering is a powerful tool in the world of data science, frequently leveraged to categorize data into distinct groups. It's all about finding similarities and grouping like with like. The process is straightforward, yet quite ingenious. It starts with the selection of initial centroids, essentially the heart of each cluster. Then, data points are assigned to clusters based on their proximity to these centroids. The centroids are recalculated, taking into account the new members of the cluster. This process is repeated, iterating until the centroids stabilize and the clusters are clearly defined. It's a dance of data, a constant shift and adjustment until everything falls into place. It's quite remarkable when you think about it, and it's everywhere. Next time you get a movie recommendation or see a personalized ad, remember, it might just be the work of k-means clustering.